I think the thing that I hadn't appreciated as much, I appreciate a lot more now, is making sure you work on the right problem. So you could get a lot of other stuff right, but if you're not working on the right problem, it may not matter.
Hello, everyone. Welcome to the Data Scientist Show. This is Daliana. Today we have Greg Tanaka. He's a computer scientist turned CEO of an AI company. He started coding when he was 6 years old. In college, he studied computer science at UC Berkeley, and later he has built many machine learning applications. He is the founder and CEO of Pika Group, developing forecast as a service. He's also the council member of Palo Alto in California and just finished his campaign for Congress, trying to use his technical background to build a better future. Today, we will talk about his career journey, forecasting, machine learning applications in blockchain and political campaigns. If you enjoy the show, subscribe to the channel and give me a 5-star review and leave a comment. Welcome to the show, Greg.
Thank you, Daliana. Really appreciate the opportunity.
So how did you get into machine learning?
It started, it started a while back. I've always been kind of involved in computer science. But what happened was we started a company called Percolata. And Percolata was, what it was doing was basically trying to figure out how much staffing a retail store should have. And in order to do that, we had to set up cameras that use computer vision to essentially track and count who's coming into a store. And then we would take that data and then use that to have a staffing forecast of how much data or how much staffing a store needed to have. So that's how we got started. Was through the company that I started. So this was like, I don't know, 2011, a while back.
Yeah, thanks for sharing that. And now you're also using machine learning to help with marketing optimization. So, and a different type of retail related forecasting.
Yeah, so we're doing a lot of so we got really, really good at forecasting.
Mhm.
And so initially we were focused on retail, but what happened was during COVID, as the physical retail stores started doing really poorly and started closing, we pivoted. And so we started doing a lot of work around algorithmic trading. So for trading of securities, forecasting is essential. So it's really important to know what's going to happen. And so we started doing a lot of work around there and eventually got into cryptocurrency.
Oh, okay. That's very exciting. So definitely want to talk more about trading and cryptocurrency. And let's start with forecasting. So can you tell us one most common use case in forecasting you worked on? For example, what is the problem you try to solve, the data you use, and the model you use to solve the problem?
Sure. So what happened at Percolata was we started with the idea that computer vision was just starting to come online. So convolutional neural nets started actually working. So computer vision actually went from this world of using things like SIFT and SURF, these kind of handcrafted features,
Yes.
and started going to more towards like neural net based solutions. So computer vision started actually working. Before, computer vision was very brittle. It barely worked. There's all these edge cases where it didn't work. The only place where computer vision really was commercial was in in factories or warehouses where you had standardized lighting, standardized controls. That's the only place it really worked because they're doing this pixel based computer vision. But as neural network based computer vision started coming online, there's opportunity to apply computer vision to the physical world. So we started our company with the idea of becoming Google Analytics for the physical world. So just like how there's Google Analytics for a website or for like a
Yeah.
YouTube channel or for a podcast,
Mhm.
physical stores didn't really have much analytics. They had point of sales data, but they really didn't know how many people entered their store. So the basic idea was that, just like with a website, like an e-commerce retailer, you knew how many people hit your website, how many people add stuff to your cart, how many people actually checked out. With a physical retailer, they only knew how many people checked out. They didn't know the top of the funnel, right? They had no idea. And so what we were doing was essentially helping them have insights to the higher level part of the funnel, like how many people actually walk by the store, how many people actually came into the store, how many people went to a certain aisle, how many people like add stuff to the cart, how many people actually checked out.
Yeah.
So it's basically help them understand the full sales pipeline. And so that's when we started. And initially we did really, really great business. And the unfortunate thing was as we did this, it collecting the data. And what we found out when we actually collected the data was that
Yeah.
sometimes the customers, like maybe the first 3 months, they were really impressed. Like, oh, wow, this is so cool. And there's like a bunch of eye candy. We had all these fancy charts and people were just like, really, computer vision became easier and easier to do, right? So now computer vision is relatively easy compared to was, back in, 2010, 2011 timeframe. And so we started getting a lot more competition. And so what we would try to do, so basically counting people started to be a bit commoditized. So we started thinking about, okay, how do we add more value to retailers? And one way to add more value is rather than just providing them the sales funnel, one thing that we found that was really valuable to them was to provide a forecast of the traffic, or more importantly, forecast of the staffing. Because if you look at a retail store, one of the biggest expenses for a store are the people, the employees. And so with retailers, the amount of traffic they have in a store goes up and down all the time. And what you want to do is you want to have the right number of retail associates at the right time. And if you do that, you're able to sell more without wasting money. Because with retailers, the profit margins are really thin. If you overstaff, you basically could go bankrupt, right? If you understaff, you could also go bankrupt because you don't service customers properly and they don't buy stuff. So it's that really delicate line. So you have to kind of make sure the staffing follows the traffic. And so we started doing a lot of work around forecasting. From the computer vision point of view, we did a lot of computer vision, but we also used audio. So we had microphones that listened to how loud it was in the store, and the loudness actually was a pretty good indicator as to how busy a store was, right?
Yeah.
And then we also used so like every smartphone has a has a Wi-Fi radio, right? And each cell phone is essentially, there's a unique fingerprint, like a MAC address that acts as a fingerprint. It's like a mobile fingerprint.
Yeah.
And so we used kind of like all three sensors put together to figure out like what is the occupancy of a store, right? So how many people are actually in the store. And we could triangulate it through the computer vision point of view. We could triangulate it through the audio as well as through the Wi-Fi fingerprints.
Yeah.
And so we use all three of them to kind of get a really good idea about the activity in a store.
Yeah. Oh, that's very interesting. Also a creative way to collect data. I think for data scientists, a lot of times we think, we just put all the data in a model and then we sometimes expect some magic, but it's actually a lot of understanding of the business. I think you probably have you ever done some research to walk in a retail store and to kind of understand how it works yourself to have better understanding of the data collection part?
Not initially, and that's one of our regrets was that I wasn't a retailer. I didn't know the retail business that well, and so it took us a while to figure this out, right? So we came in as technologists into an industry we didn't know that well, but looking back on it, really understanding the problem, truly understanding the problem, is critical. So, for instance, initially we were really into like collecting the data. And what we found out when we actually collected the data was that sometimes the customers, like maybe the first 3 months, they were really impressed, like, oh, wow, this is so cool. And it's like a bunch of eye candy. We had all these fancy charts and people were just like, really, really excited. But then they didn't necessarily continue or continue the purchase, continue the subscription to our service. And it's because a lot of times they didn't know what to do with the data, right? They didn't know what action to take.
Yeah.
And so, so understanding the business problem well is really critical, because you could do some really fancy technical thing, but if it doesn't drive business value, it doesn't matter. And that's why we figured out we had to actually forecast the staffing, right? Because there's one thing, just collecting the traffic data is not enough for them to figure out what to do. It's not that actionable. But if they actually have a forecast of the staffing, it's really actionable, because they know that, we staff this many people at this time. So it's very actionable. And so that's something where, looking back on it, it's kind of obvious, but it wasn't obvious at the time we got started.
Yeah. Yeah, thanks for sharing that. That's a great lesson. And so you have basically three sources for data. And I can imagine when people walk around the store and also the audio, Wi-Fi, it can be a lot of noises. So when people walk by, maybe this is like a popular road, people just walk by, the traffic doesn't really matter. And then the audio, maybe someone else is playing something. So how do you do some feature engineering or further do some data selection to see what are the, the images or the footage or the audio are real signal versus noise?
Yeah. So it's actually kind of interesting because each modality has a strength and weakness. So with computer vision, you could get a really fairly high level of accuracy where someone is, right? Like the person's exactly right here because you can see them. With audio, you can't really do that, but you could get other things. You get things like sentiment, right? You could hear. You can't actually know what people are saying because you can't really quite do that, but you could tell by the kind of the type of noise, right? What's happening, right? And computers are also good at measuring speed of people. So how fast someone walks by the front
Okay.
of the store.
The temporal of the frames.
Yeah, exactly. And then like the Wi-Fi is also really interesting. The mobile fingerprint is really interesting because you could get things like how many times had that person been there before. So you could tell whether it's a new fingerprint or a one that that we've seen before. So it's kind of like a mobile cookie. It's like a cookie on a browser, right? Almost. So so each of these modalities has a strength that you could leverage, right? And so by fusing the data together, you get some really detailed information about what's going on.
Yeah. So if just have one set of modality, maybe sometimes we have a lot of noises, but if three of them, I think it's easier for us to use, kind of as a safety check. Do they tell a consistent story? And then it's also easier for you to know what's really going on behind the data.
Exactly.
Yeah. And for the computer vision model you mentioned, right now, I think with a lot of pre-trained model, I think a lot of times based on my own experience, unless you're developing new algorithms, it feels more like an engineering problem than the, data or the science problem. You can just load a pre-trained computer vision model and then fine-tune the last layer. Or for some common object detection like humans, you can just directly use it. So are you able to share some typical computer vision models you use? What are some models you find that works better in this case?
Yeah, because we did this, when we did this, there weren't that many people doing it. There was no Hugging Face. There was no now it's really easy because like there's all these great models out there and they're all pre-trained and, they work pretty well. But back then, during the early days, all this stuff didn't really exist. So you had a lot of the stuff you kind of had to do. TensorFlow was at the time we started hadn't come out yet. So this was super early days, and so at that time it was difficult, right? Just getting a good data set. I remember we spent just a ton of money just labeling data, just to get a big enough data set. And now there's ton of data sets, so it's a lot easier now than before. But one of the like, for computer vision, one of the things that people don't think about is in production it gets to be really expensive, and that was one of the issues we had was that the cost of what we were doing and the amount that customers were willing to pay was pretty close. So the margin wasn't great, right? And there was a lot of competition doing this. So the margins kept going down and going down. And so the challenge with computer vision for doing video computer vision for video, the real big challenge is how to keep the cost down, because you could certainly do the counting and all that stuff, but can you do it profitably? That's the challenge, right? Yeah. So I mean, directly you could have hardware on site, right? We tried that as well, but it gets to also be a bit expensive because you have to deploy stuff. And also you have to keep it up. That was the other big issue, is because, and you don't think about that a whole lot, but like if you have a lot of people have surveillance cameras, ring cameras, they have, but these things you have to kind of reboot them every so often, right? Because sometimes they stop working, right?
Mm.
And and so just that physical, keeping the physical things going is actually
Yeah.
harder than you would think, and
Yeah.
especially because a lot of these things are placed in hard to reach places, like like hidden or out of sight,
Hmm.
and so servicing it is hard actually. It needs a truck roll. It could become expensive.
Yeah. And hardware is hard.
Hardware is
Um,
hard. Yeah, yeah, definitely, yeah.
so yeah, I don't know if this is your secret sauce. So how would you able to share? How did you manage to keep the cost low in the early stage?
Yeah, initially we actually had our own sensors, right? You had a sensor that
Mhm.
that did all, that captured the fingerprint, captured the audio, captured the computer, the video. At that time, the hardware to process all this on chip was actually kind of tough, and it was also hard to transmit this data back. So we had to use really small models, like MobileNet, right? So MobileNet's a small model, and now of course the hardware is so much faster and it's a lot easier now. But back then it was actually pretty tough. And
Mhm.
so you had to compromise. You had to compromise on quality. So that means the accuracy wasn't quite as good. Your sensor fusion wasn't quite as good. You had to do a little bit more in the cloud.
Yeah.
Um, then there's connectivity issues. There's all these kind of things that make it difficult.
Hmm.
But of course, as chips has gotten faster and cheaper, it's like it's not as hard to do, right?
Yeah. Right. And you mentioned in the beginning you have to make some compromises. What are some other important trade-offs you have to make when you develop this product?
You know, there was so many different trade-offs. One thing was just as a price as a price for accounting people in retail stores was plummeting. We had to keep figuring out how to get our costs down. And eventually, what we did was we decided just to use the surveillance cameras in retail stores. But then you run into a new issue, which is how do you integrate to those surveillance cameras? And there's some standards, but they're not exactly the same. So there's still integration work that you have to do. So that's
Hmm.
when we drove down some of the costs, was not to do not to have our own hardware anymore. But then we lost some things, like we lost the ability to do the mobile fingerprint. We lost the ability to do audio. But basically, one of the reasons why losing the mobile fingerprint wasn't as big of a deal was because Apple started scrambling the MAC addresses. So before the MAC address would always stay the same, but to protect privacy, Apple started scrambling it. So the
Mm.
mobile fingerprint lost its usefulness, right? As a
Oh,
doing new versus repeat. So that's one of the reasons why we thought, it would be nice to have, but
right.
um, you know,
Yeah.
as it got scrambled, then Android started doing the same thing. So it
Mhm.
just it wasn't as useful as it used to be.
Yeah. And it's great that in the beginning, the model wasn't so heavily relying on that. You kind of diversify the risk while
Yeah,
you have kind of three modality.
yeah.
Yeah. And for the audio part of the model, so I'm not super familiar with the audio. So can you share a little bit how do you process the signal? Is it kind of similar to some language model time series?
No,
Is it like,
ours is really simple. I mean, when we first started, it was super simple. We just decibel level, right? It
oh,
sounds
okay.
so stupid, but
Yeah.
actually, if you want to know so the problem that we're trying to solve is how busy is the store? Okay, like how
Mhm.
busy. And actually, what's really interesting is how much talking there is, how much volume. It's like the cocktail party effect. So more people in the store, louder people will talk. You don't even realize you're talking louder, but you are, right? And so the audio levels go up. And so audio turned out to be like we just looked at decibel level. That's it. No fancy models, nothing. Just
Yeah.
just decibel levels. And it turned out to be a really good indicator as to activity in a store, right? I mean, a really
Mhm.
good indicator. And it's just we just simply no fancy models, right? Just
Yeah.
how loud is it?
Wow.
Yeah,
Yeah, that's very interesting. So sometimes some simple approaches it
yeah.
works. Yeah. And so you mentioned so after you build this model, you're able to count.
Well,
Uh,
I'll tell you one thing. We took an audio level, but you do have to put it into a model to kind
right.
of calibrate it, right, so to speak.
Mhm.
So you take it in decibel level, and then you take it as a feature, and then so this goes into another model. So, but the raw signal itself was surprisingly good.
Okay. So what is the another model? Is it like also kind
Well,
of?
what we
Mhm.
had was we had our computer vision model, right,
Yeah.
and this outputted like a count of people,
Mm.
like a count of people as well as like is it a salesperson or is it a shopper? right?
Mm-hmm.
We had the Wi-Fi model, which basically said, here's not Wi-Fi model, but the Wi-Fi sensor, which was how many mobile fingerprints do we see? How many of them
Yeah.
are new? How many of them are repeat, right? But of course, as Apple started scrambling them, that new versus repeat started like not being as meaningful. And then we
Yeah.
had the audio signal, which was volume, right? So all of
Mm-hmm.
that fed into a model which fused it together.
Mm, got it. So for this model, because you have a few other models and components, did you have any requirements for latency, or this type of analysis and
No,
forecasting can be?
no, because we the end application for us was how much staffing did the store need, and so this
Mhm.
would so basically um, we had the model which fused all the sensors
Yeah.
together, and then this fed into a staffing forecasting model
Hmm.
that
Got it.
forecasted how much staffing the store needed.
Right. And then for the forecasting model, is it mostly based on the tabular data of the kind of the traffic, more like a time series model?
Yeah, it's a time series model, but we had to take in like holidays. That's really important.
Mm.
We had to factor in weather. Weather is also really important, surprisingly important. You have to also factor in the marketing calendar. So like are they doing a big promo or not? So those are some of the major features we would use, and that would help you forecast what was going on.
Yeah. Promo holidays. I remember when I was working on those type of projects, so a lot of times I have to do some kind of add some hard-coded feature. For example, around Thanksgiving or like Christmas, the type of behavior is always different. So for forecasting, do you have a favorite model? Do you like to use some deep learning models, or do you
Yeah,
use a tree-based or more traditional approach?
you know, time series forecasting is actually kind of hard, and the reason why is because unlike like computer vision, right, where you're trying to have a model recognize a cat versus a dog,
Yeah.
it's easy to get more labels for cats and dogs, right? You just take more pictures, so it's not that hard. But with time series, the big challenge is you can't generate more time, right? So fundamentally, it's a super big issue compared to non-time series. Non-time series is actually easier, and so I think a lot of the machine learning techniques have been more successful um, with non-time series type of problems. With time
Hmm.
series types of problems, because you're limited by to how much time you have, and that's
Yeah.
usually the limiting factor. Is almost only so much data,
Right.
and how sophisticated a model you use really depends on how much data you have, right?
Yeah.
Because fundamentally you can't have less data than you have. The model has to be smaller than the amount of data you have, right? So if you have you know a million data points, your model has got to be well under a million parameters, right? In order for you to train it properly. So that's the big challenge with time series. Is it's um, you're limited to the amount of data that you have, and and
Hmm.
and, and also fundamentally the issue is that it's the amount of data and granularity of data you have for whichever feature you're using, right? So you take
Hmm.
a thing like the marketing calendar, it's not updated that frequently, right? It's like maybe once a week, maybe once a day, right?
Yeah.
Um, Now, traffic, of course, is very granular. You can get every second, so that's very, very fine grained. So you have more data because it's more fine grained. But
Hmm.
things like the market calendar may not be so fine grained. So it gets to be challenging because um, you want to use the more powerful models, right? But
Yeah.
the problem is that um, your data set has to be able to handle it, right? And if
Hmm.
it can't, you can't use fancy models. So a lot of times, what you do is you cascade models together. So you keep the data that's more fine grained together, and the stuff that's less the coarse grained, you'll have a separate model that they'll cascade into. Or
Mm.
I guess the word is ensemble. Well, ensemble them
Ensemble
together. Yeah,
approach. Yeah. So for example, maybe you have like some type of hourly model, and then you aggregate some data, have like a daily or weekly
yeah,
models, you have them together. And because, you know, also basically dealing with different type of seasonality. They're like
yeah,
24 hours and seven
yeah,
days and
yeah,
yearly. So I think, yeah, this type of ensemble solution kind of works. And I like that you mentioned there's more kind of fine grained, different level of details, and also time series. You do need to kind of understand those details instead of just feed them into a kind of complex model. Yeah.
yeah. I mean, a lot of times People want to use the biggest, baddest model they could find,
Right.
but if that data set can't support it, it's like not going to work, right? Simply not going to work. And so that's something which you got to fit the right model for the problem that you're trying to solve.
Yeah. And for time series data, I think another challenge, one challenge you mentioned, you cannot kind of simulate a lot of future data. The only real test you have is to test again the real data and then
Yeah,
compare. And sometimes people's behavior change, or the store
yeah,
they change strategy, so you have this kind of data drift problem. So how do you handle this? How do you retrain the model?
yeah. So I think when you're testing, so when you're doing non-time series, it's fairly easy, right? You can you can have a randomized test and train split, right? And that's not a big deal. But for time series, you can't do that, right? Because
Right.
you can't sample, you can't have the train data after your test data because you have a causality issue, right? And so you have to keep the data in order. So what you could do is what's called expanding window. So you could have your training set and it could expand out, and then you could have your test set kind of slide along as the training window grows, right?
Hmm.
And so, but yeah, it's having a stable forecast is actually kind of challenging because like of all the things you said, but the biggest challenge really is just the data sets for time series tend to be relatively small compared to non-time series. And you can't generate more data. That's the biggest problem. The only way you can generate more data is you go to finer resolution.
And how do you solve this challenge? What are some approaches you have tried to make the forecasting more stable?
Well, I mean, like I said, you can go to finer grain. You go to finer grain models. I mean, sorry, finer grain data sets. You could use fancier models. You can augment it with other signals, right?
Hmm.
Other types of features. So the way you can think about forecasting is, and by the way, I teach a class on forecasting for algorithmic trading, right? So that's something I do that every Thursday
Oh, nice. Where
um,
do you teach the class?
on Luma Wealth. Luma Wealth, yeah. And they have a lot of other courses on like algorithmic trading, but I teach
Hmm.
one on machine learning. Yeah, the challenge with forecasting is fundamentally, if you think about what forecasting is that you have all these different features coming in, right? So
Mm.
maybe it's traffic, right? Maybe it's a market calendar, maybe it's the weather, and each of these features there's a certain amount of predictive signal in each of them. And what you're doing with the models, you're trying to mine that predictive signal out of each of those features.
Yeah.
But fundamentally, there's a limit to how much you could get, right? And there's diminishing returns, right? So in fact, if you were to watch, like if you graph out how much predictiveness you get out of a signal, it diminishes over time, right? You put more effort, but the amount you get is less and less and less.
Hmm.
And when you start tapping on how much prediction you got from that signal, you got to add more, right? Now the problem with
Yeah.
adding more features to your model is it
Mm.
requires you also to have typically a bigger data set, right? And so
Yeah.
it's like the problem is very constrained because you of course you want to be able to add more features, but in order to add more features, you have to have more data, right?
Right.
More time to get
Mhm.
to figure out the correlations. And so time series tends to be very tough because of that, because of the fact that you're limited amount of data. The resolutions tend to be different between different data sources, and the amount of historical data you have for each data source is different. And so it's challenging as a result.
Hmm. Yeah. And so sometimes when we work on time series data, you observe there's a big spike or there are drops. And for data scientists, we do a lot of ad hoc analysis to understand why. And sometimes you figure out the reason, but a lot of time it's just assumptions. So when you observe those type of events happen, what is your approach to understand the data and the model?
Well, kind of like the process I like to use is, you first start off with like exploratory data analysis. You've got to look at the data set, kind of figure out what's going on, try to
Yeah.
figure out like correlation matrices, and you start like, do some histograms. You got to kind of get a feel about what's going on with the data.
Mhm.
Then you come up with some ideas of possible experiments you want to run, and then you code up those experiments, you let them run, and then you look to see how the experiments did, right? Did it match expectations or not? And then
Mhm.
based on that, you come up with a new set of experiments. and then you do it all over again. Right?
Yeah.
So you kind of it's a very iterative process because it's hard to know ahead of time. It's the way I think about it is you're kind of like a teacher trying to teach a student, right? So you
Mhm.
try to teach one thing, and then you see if the student actually like learned it, and if
Yeah.
not, you got to modify your lesson plan and try again, right? And so
Yeah.
you're like this teacher trying to teach this student, except the student is very dumb, right? So and so yeah, you have it takes a lot of kind of like trial and error, a ton of trial and
Mhm.
error, right?
Yeah. So I think, most of the time we're also doing something similar. You have those assumptions and you do some small experiments and then test different type of assumptions. And then um, sometimes you can maybe create a shadow model to split your traffic to see, which one works better, and then do some selection, kind of A/B testing your model as well. So during the pandemic, is it your pivot to do more trading happened during
Yeah,
the pandemic because of the
yeah. Physical retail wasn't even doing well before the pandemic, right? And then after the pandemic, with the COVID and all this stuff, like, oh my God, a total disaster. So
yeah.
all these physical retail stores started shutting down. And so, we had kind of to ask the question, what do we want to do, right? Because providing, you know, for retailers, right, providing them a staffing forecast when their store is shut down or, when they're at minimum staffing doesn't really, um, not a useful business proposition. Let's put it that way, right?
Yeah.
So we started thinking about, okay, who really cares about forecasting? And as it turns out, people trading securities really care about forecasting. They care about it a lot. And
Right.
so it turned out to be, there's a lot more demand in that area, right? Because it's something that, if you think about what is the essence of trading, it's a forecast, right? You're forecasting something that's going to happen, right? And so that's how we started getting into it because, our traditional market retail was just falling apart, right?
Yeah. And is it a completely new domain for you to
Yeah,
get into security trading and later
yeah.
crypto?
Yeah, I mean, although I've always traded myself personally, so
Mhm.
actually, even though it was a new domain for the company, it's something which I knew probably better than I did retail. Because in retail, I never actually. It's like some people actually like in high school, or whatever, they work in retail stores, or
Yeah.
they shop in retail stores. I never actually did that. I'm not a big shopper, and I never
Right.
actually worked retail. So I knew I knew I hadn't realized how little I knew until I got into it, and then I realized, oh man, I really don't know this stuff very very well. Um, I learned it, of course, but I didn't know it about very well. Now I know a lot about retail, but at the time I didn't know much about retail. When I first started, and after college, when I first started working, I did a lot of option trading,
Hmm.
and for a while I did so well that I was thinking about. In fact, I did so well that I made 4x my own salary, like working for someone else as an engineer. I was designing GPUs,
Right.
but I was just killing it in terms of like option trading, and I was thinking, oh, I'm going to quit my job and just do option trading full time. And what I hadn't realized was I was just lucky. Okay, I thought it was just awesome, but
Mm.
as it turned out, I was just lucky because while I made a lot of money at one point, I also lost a lot, right? And
Yeah.
and I realized that the challenge here is not just to do well once in a while; is to do well consistently. It's actually very very difficult. And so yeah. So, but anyways, I had a lot more experience with just trading in general than I
Mm.
did with retail.
Yeah. Well, I think you said something really important. It's not like something you just do it one time, like win the lottery. If you
Yeah,
want to do it as a profession, you have to do it well consistently. And I think it's sometimes very difficult to separate. Even as a data scientist, you train a model, it performs well. It could also become because we got lucky on a specific,
yeah,
split of train or
yeah,
test.
yeah. It happens
Um,
all the time, all the time. That happens all the time. Yeah, it's crazy.
Yeah. And also it kind of hurts our ego. You realize, oh, I was just being lucky. So a lot
Yeah.
of times it's hard for us to accept the fact and really, look at what's really going on. So for you, what are some lessons or what are some of your approaches to being more objective when you look at the performance of your model or portfolio?
The amount, like especially for algorithmic trading, the amount of back testing you have to do cannot be underestimated. A lot
Yeah.
of times, people like to, you know, try a small, test and, like, oh, wow, it's working. Let's roll out live. And that's just disaster, right? So what you do is you backtest the heck out of it as best you can. And then you do paper trading, right? You put it live and you do paper trading and you see, how well does it work, right? How stable is it? How consistent is it, right? You can actually
Yeah.
measure what's called a Sharpe ratio, which is a way of measuring performance, like how much performance versus volatility. And then if everything looks good, then you go live, right? And you go live with a little bit of money, not too much, right? Just a little bit of money.
Right.
And then but one thing about algorithmic trading is that it's like milk. It spoils over time, so it doesn't, maybe initially when it comes out, it's actually pretty good. But what happens is I think other people kind of figure this out too. And then so there's nothing there's no such thing as a evergreen model that's,
Right.
good forever. It's kind of
Yeah.
like it's an active market, so everyone's competing against each other.
Right.
So the performance drops over time, right? And then
Mhm.
it's like a treadmill. You have to keep on it, right?
Yeah. So for the approach using machine learning, I know you have a whole course about it, but for our audience today,
Sure.
are you able to give us maybe just a kind of quick overview or like a mini masterclass um, on this topic?
Yeah, there's traditional indicators. So like Bollinger Bands, there's, rolling means, there's a whole bunch of um, technical indicators that people use to trade.
Mm.
And in the past, they weren't that bad. You could actually make money doing this kind of stuff, like doing it manually. But today, the majority of trading is actually algorithmic. And if you're trying to do this stuff manually, it is crazy hard. And in fact, I think that's why a lot of kind of like traditional technical analysis type of trading has kind of gone to the wayside, just because like so much of it is done algorithmically, and they could react way faster than any human could do it, right? They could press that buy or sell button much faster than any human.
Yeah.
And so the only real advantage that especially like individual investors have is to use um, like better models, right? So these technical indicators are, it's like a very simple model, right? It's like a linear model or something very simple, or like a mean or something really simple. It's like, these models, the traditional technical indicator models have like 1 to 4 parameters, right? So they're dead simple.
Yeah.
Um, and so by using fancier machine learning models, you can you can find more complex patterns. You can come up with a higher level of accuracy, and generally for algorithmic trading, like doing Warren Buffett style of trading, where like Warren Buffett buys like a Coca-Cola and he holds it for 20 years.
Mm.
That kind of stuff is better for humans to do. That kind of like long-term trading, but machine learning is really good at short-term trading, right?
Hmm.
Where because if you go, because you could use finer grain resolution data,
Yeah.
and then and predicting, accurately 10 minutes in the future is not so hard. Predicting 20 years in the future, you need like a human like Warren Buffett to do it, right? Because humans do better when there's low amounts of data, but machine learning does better when there's large amounts of data, and so higher frequency type of trading does better.
Hmm.
So what you need to do is you need to build models that are able to incorporate this kind of data, and then there's also a non-time series aspect as well, because sometimes there's like externalities happening, right? Maybe a new competitor, or um, maybe COVID or something like that. There's things there's outside things, so you have to also factor those in. But it's the basic principle is like you got to think of yourself like a miner. You're trying to mine for gold, right? In this case, you're trying to mine for nuggets of predictive power, and it's really important that, and a lot of people just don't do this because it's kind of boring, right? But what's really important is logging your experiments, right? So you can see where you are. Because the way
Mm.
you have to think about it is you're like a mouse in a maze and you're trying to find the exit, right? And you
Yeah.
gotta remember where you went, right? So
Right.
you don't repeat the same mistakes you made before. And so that's
Yeah.
why logging is really important. And actually using the scientific method is actually really important to
Hmm.
kind of figuring out the solution, right? So when you make an experiment, you should have a hypothesis as to why this is going to work. It may not work, but at least you should have. But a lot of people they're not very methodical about it. So they just kind of try a bunch of random things, like it takes forever for them to converge and get a good result. But if you take a very scientific approach, you can do a pretty good job. Um, and then so that there's a forecasting side, and then the second side of it is how do you so there's a forecast and then there's a trigger. When do you trigger it, right? So like when you buy and when you sell, and there's very simple triggers like if the price is higher, buy. If the price is lower, sell, right? So
Yeah.
there's simple triggers, but then especially for like low float stocks that have are thinly traded, you could start using really fancy triggers like reinforcement learning type triggers where you can because RL does really well when there's low number of players, right? Because you could basically because then the RL model could kind of play itself, and then there's like this game theory stuff going on, right? But when
Yeah.
you're talking about large cap stocks or largely traded stocks like Tesla, forget about it, right? You treat that just purely as a forecasting problem. So there's two parts to trading. There's the forecasting, and then the other part is the trigger, which could get pretty complex depending on what you're doing.
Right. So forecasting is basically, are you just forecasting the price, and a trigger is more like how do we use this information to make decisions?
Exactly.
Yeah. And it's
And both are
interesting.
both are important, right?
Yeah. Yeah.
Yeah.
And so it's interesting you mentioned reinforcement learning, and you mentioned when there's a low volume, it's easier for you to use reinforcement learning, but it's hard to do that on like the kind of
Yeah,
population.
because the way reinforcement learning works is that you have two agents, right? Two models,
Mhm.
and they're basically fighting each other, right?
Right.
And um, and it works well when there's like low number of players because they can actually fight against each other.
Mhm.
But you can imagine if there's like 10,000, it's really hard to uh, simulate that, right? And
Yeah.
RL works well when there's not that many when it's like what do you call like a low float stock or
Hmm.
low float asset.
Yeah. Yeah. I was just interviewing another data scientist talking about reinforcement learning's use case. It's very exciting that previously when we think about RL, you just think about like gaming, robotics, but
Well,
now.
gaming and robotics is great for it because, like gaming, you're firmly like you're playing another agent, right? So it's
Mhm.
the great thing. Okay, the great thing about reinforcement learning is that it generates its own training data, right? So you
Yeah.
don't have to
Right.
have a gazillion labels, right? Versus
Yeah.
supervised learning, you have a gazillion labels, right? So reinforcement learning, fights itself, so it generates its own training data, which is great. But the problem
Mhm.
is that games are great because you have this game machine you're playing against, so you generate training data pretty easily. Or like if you're playing like Go, you have two Go things like AlphaGo. You could play two AlphaGos could play against each other, so it works well. Or like thinly traded stocks, you could have a few RL bots playing against each other, right? And so that works well. But
Yeah.
it's hard to. Not all problems are set up like that, right? You can't like if you're going to recognize cats versus dog. There's no way to do it with reinforcement learning. There's no kind of easy setup for that.
Hmm. Yeah. I know you have worked on some project using GANs. Is it similar? You build some adversarial kind of models and then using reinforcement learning to
Yeah,
train.
so I've done a lot of work with GANs. I've done a project where we're essentially um, it's kind of a retail thing, e-commerce, right? Where you have someone wants to see how do they look at the clothes that they're going to buy, right? So you have to basically morph the clothing onto that person. So um, I'm not sure if you heard of Pix to Pix, but generative adversarial networks. In that situation, there's like a generator and a discriminator, right?
Yeah.
And they're trying to fake each other out. The generator is trying to make a picture that the discriminator thinks is real, right? And so
Mhm.
that's why you call it generative adversarial network. And so
Yeah.
it's kind of like RL where they're kind of fighting each other.
Right.
Um, there's like it's really cool technology. There's something called Pix to Pix, right, where you could draw a mask of something, and then it will render a realistic looking picture. It's actually very cool. So, and there's a lot of neat demos on the web on this kind of stuff. So you
Mhm.
could do things like morphing clothing onto people, as an example,
Yeah.
right?
So what application did you build using GANs or
Well,
what?
basically, literally morphing clothing onto people. So you could,
Oh, okay.
see how you look in the new sweater or new dress, or,
Mhm.
so it looks like you actually are wearing it.
Yeah. And what is some challenges when you build this project?
Oh, with GANs, the big challenge is unlike with supervised learning, right, where you're just trying to get the lowest possible error rate, you know, you get kind of like mode collapse, so to speak, where essentially, either the generator or discriminator could just win, right, and the other one can't recover. So it's very tricky to because you have these two things fighting each other, and you have to make sure that they're kind of balanced, right? You can imagine like if you had like one person who's like, it's like playing tennis, right? You can imagine if people at the same level, they could kind of, they could they help each other get better and better and better. But if one player gets too good versus the other player doesn't learn. It just gets like wiped out, right? So that's the problem with cancer. You gotta keep them kind of at the same. They gotta kind of grow together, right?
Mm-hmm. Yeah, that's very interesting. And going back to trading, so later on you also worked on trading crypto. Are those cases similar to security? Kind of what is the difference and similarity between trading traditional financial assets versus cryptocurrencies?
So I think the neat thing is, first of all, crypto is 24/7, right? It's 24/7, right? And yeah, and then also data is easily accessible because it's all on the blockchain, so that's kind of cool. And the level of innovation is way faster, way faster, right? Versus traditional finance. And so I kind of came up from the machine learning angle, but I've become a real big fan of crypto just because of the potential. I mean, if you look at the U.S. economy, about 10-20% of the U.S. economy goes towards traditional finance, right? I mean, the people on Wall Street. And so basically, Wall Street is exacting this relatively heavy load for handling the finances of our country.
Yeah.
But with crypto, you could basically do a lot of that at a fraction of that load. And so it's a way to get much more financial efficiency in our country. Yeah, I mean, I think ML for crypto is not that prevalent, right? I think it's right now a lot of this stuff has been used for the traditional finance, like trading stocks. But with crypto, it's just starting to merge, so there's more of it. So one of the protocols I'm working on is called Mosaic Finance, and what it is it's kind of like an auto balancer. So it predicts the price of the token, it predicts the price of the APY, and then auto balances between them to maximize the yield. So there's I would say this is like the Wild West. It's like early days right now in the crypto world, and so there's lots of opportunity as a result.
Mm-hmm. Yeah, that's very exciting. And what are some other use cases for machine learning in not just crypto, but like blockchain?
I think that both of them are relatively new technologies, and relatively, right? Because really come on their own in the past few years.
Yeah.
And I think that right now I think the big one is for trading, like forecasting. Machine learning is just really critical. Mm-hmm. Because you're trying to forecast, you're trying to make money. This whole area called decentralized finance is really really becomes important. But there's a whole new area of crypto that's actually quite interesting, which is what they call Web3. Mm-hmm. And so Web 1 is essentially kind of like Yahoo in the early days, where it's just a web page and you just kind of read what's on there. Web 2 was the idea of like Twitter or Facebook, where there's a lot of user-generated content. And then Web 3 is this idea of ownership. So Web 1 is read, Web 2 is write, and then Web 3 is like own. So it's read, write, own. So you basically, the neat thing about it is that the end user owns their own data, has control and sovereignty over their own data, and it leads to the ability of being able to build apps, or what they call dApps, decentralized apps on top of each other. And so I think there's I think pretty much we're going to see every Web 2 application become a Web 3 application. Mm-hmm. And I think it has a potential perhaps of being bigger than Web 2, mm-hmm. Web 2.0, right? Mm-hmm. And then at the same time, you look at machine learning. 10 years ago, very few applications actually use machine learning, but now you see machine learning in just about everything, right? I mean, yeah. I was looking at the latest Apple, iOS release, and it has this thing where you could like select a person, and then you could drag just the cutout of that person to your iMessage, right?
Oh, really?
And then we all know about the predictive ability of, like, you type on the keyboard and predicts what you're going to say, right? And we know about the speech recognition. And I mean, machine learning is becoming kind of like, it's becoming standard in everything. There's almost no application now that doesn't have machine learning. And so what's interesting is you have crypto on one hand, or Web3 on one hand, and then you have machine learning on the other hand. Both of them are becoming much more prevalent. I would probably say machine learning is probably more prevalent right now than crypto, and maybe has a little bit more utility than crypto. But I think together, there are actually some really interesting applications. So I could see that, there'll probably be, I think most Web3 apps probably don't use much machine learning right now, but I can see that eventually will be there, because if you look at Web2 apps, almost all of them have some sort of machine learning functionality in there, right? So, like, whether detecting your that post is spam, or whether you're violating someone's copyright, or like what post should you see next, like a TikTok, right? It has an ML engine, a recommendation engine, that recommends what you should see next. So I think it's natural that you're going to see ML go into Web3 stuff. I think the big challenge though right now is that for most part, machine learning, you can't really do it on chain. So in the crypto world, there's an idea of on chain versus off chain. On chain, okay. So what you mean by on chain is that these contracts that are like the Solidity contracts that are executed on Ethereum or Avalanche or one of these chains is essentially a software program. That's what you mean by on chain. Yeah. But the computation ability of doing stuff on chain is like the Stone Age compared to traditional computing. So it's really hard to do machine learning on chain right now. So most of the machine learning that's happening is happening off chain, right? And then all the predictions are passed on chain. But I think as blockchain and Web3 evolves, we'll probably find more performant versions of machine learning. So some of the stuff could be done more on chain. But right now, as a Solidity developer, you try to minimize the amount of computation that you have to do on chain. You try to just have the bare bones basics there, because the computation sucks so badly, right? But but it's like now today compute, like everyone writes in Python because performance is not that big of a deal. You don't have to write in C++ anymore because you don't have to worry about performance. But like in Solidity, it's kind of like Back to the Future, where you have to use this, you have to keep things relatively simple, and you don't have that much you can't do too many fancy things because of just computation limitation, from storage to compute power to everything. It's just not there, right, compared to what you can do off chain.
So I'm not an expert in Web3, but when I think about a decentralized application, when you make a proposal or there's something happens, it have to be kind of verified by everybody. So when you talk about the speed for doing machine learning on chain data, so besides you talk about maybe some infrastructure challenge, but the nature of Web3, do you think is also make it hard to do machine learning on chain?
It's very hard because it's slow, and they charge you what's called a gas fee, right? So every bit of computation you do, you get charged for it, right? So computation we do right now, like off chain, like we would do, we don't think too hard about because compute power is plentiful. But for Web3, the computation you're able to do on chain is like you have to think really hard about it. You have to make sure that everything you do is really needed, because every little bit you're charged for it. And so you got to keep it to a minimal, right? And then the gas fees is actual real cost, that cost to run. Like you can think about like AWS, right? There's a cloud, right? You have to pay AWS money, but the amount of money you would pay on chain to do this computation is it's like orders of magnitude higher than you would do it paying AWS. For AWS, it's so low that you don't have to think too hard about it. But when it's on chain, you have to think really hard about it all the time, because it's like the computation is so expensive, it's so limited.
Yeah, thanks for sharing that. So now you have also tried to go into politics. So what made you want to get into politics? Especially, I think during your campaign, you talk a lot about blockchain. What do you feel is kind of lacking in the current political environment?
Sure. Well, I didn't. So if you read your book in high school, it would be the kid most likely not to run for anything. So I was a pretty nerdy kid. I was still really nerdy. I was very much into science and math, right? And then, I went off to Caltech and then Berkeley, and then I did some work at Stanford. Really, this is all electrical engineering, computer science. So I was, very, very engineering focused. For me, kind of like what got me started on all this was I was living in a condo in Mountain View, and I lived on the 3rd floor, and the laundry units were on the 1st floor. And to do laundry, I had to walk down all these flights of stairs in this coin op, right? So it was not convenient at all. And so I went to the HOA board and asked them, hey, can I get a laundry unit at my place? And they said, no way, right? But they said, we have an opening for a treasurer. And in most HOAs, they're looking for volunteers all the time. Mm-hmm. And so I volunteered to be treasurer, and they got to know me. They said, oh, it's a great idea. Yeah, no problem. You can get a laundry unit. And so I found out that, you could sit around and complain about stuff, or you could actually get involved. And so what happened was, later on was the mayor of Palo Alto was trying to ban software development in our city. This was back in 2016. And for me, I'm running a SaaS company, a software as a service company. I thought the idea of banning software development, this is where HP started, this is where Google started, this is where Facebook started. The idea of banning software development is just crazy. I think we want more innovation, not less. Mm-hmm. And so that's why I ran for city council, and I won. And one of the first things I did was, push for the legalization of software development. I'm involved in politics. That's how I got into city council, was just because I really believe that innovation is really important. And then shortly after my re-election to city council in November 2020, some of my supporters asked me to start looking at running for Congress. And one of the reasons why is because the current incumbent, she's 80 years old and not terribly technically savvy, let's put it that way. And so she has bills like she's trying to ban recommendation engines, basically prevent or make it difficult for companies to use recommendation engines in their product. She calls them dangerous algorithms. And then the other thing was she voted for to have it to basically make it very difficult to do crypto. So the infrastructure bill is a large spending bill. It's a multi-trillion-dollar spending bill, and what it does is they needed someone to pay for it. So they looked at the crypto people and they thought, well, these guys aren't really paying their taxes. So what we're going to do is we're going to make all of them report on each other, so that they can't do any crypto transaction without that being reported to the IRS. Yeah. And in the course of doing that, they made it so that if you're mining a Bitcoin transaction, you have to, or a Bitcoin block, you have to report all the counterparties involved in that block, which is literally impossible to do in crypto because you don't know the person's real name, you don't know their social security number, you don't know their address. So it makes it very difficult to comply with that law. And what that means is that, basically almost everyone in crypto now is a felon, right? And so what you're seeing is you see a flight of talent, especially in the crypto space, out of the countries, right? So like Sam Bankman-Fried used to be here in the Bay Area. His parents are Stanford professors, and he moved to the Bahamas, right? Mm-hmm. And you see all these kind of what they call OGs, right, of crypto moving away to other countries because of how difficult the laws are here. And I kind of see crypto where the internet was in 1995. I think it's just starting right now. Mm-hmm. And what we want to do is we want to encourage more entrepreneurship. We want to encourage the development of new technologies here in our country. We don't want to drive innovators away. And so I felt like I need to step in. It's very much the reason why I stepped in and ran for city council was because I want innovation in Palo Alto. I don't want it to leave our city. I want Silicon Valley to be as vibrant as it is. And I think the loss of this new technology would be terrible for our country. And so that's why I stepped in. And, the nice thing is I've seen a lot of the people on the campaign trail started adopting crypto, right? They started making it. They started becoming pro crypto candidates, and that was great. I don't know. I think the current incumbent still is not terribly supportive of crypto, unfortunately. But I'm hoping that there's more pressure on her to kind of be supportive, at least not antagonistic against this technology, because so there's crypto by itself, which is just all these crypto tokens, right? Which a lot of people think are Ponzi scheme, but what's happened is all of these cryptocurrencies have they have bridges to each other, and they're forming this foundation of what's called Web3. I talked a little bit about that.
Yeah.
Web3 has so much promise in that, with Web2 technology, the sign-on process to a new service is really high. Mm-hmm. So you have to feel really motivated to sign on, because you have to put your credit card number in, you have to put your name in, your address in, you maybe have to import data into it. There's a lot of setup involved using a new software as a service application. So you're kind of reluctant to do that. And then the other problem, of course, is you're locked in once you're on there. Like if you're on Twitter or Facebook or LinkedIn, it's hard to get off because all your data is on there. You can't take it with you. There's not much portability. And as a result, also the applications are not very composable, right? They can't be built on top of each other. But with Web3, all these applications can be built on top of each other. The user owns the data. They have sovereignty over their data. So mm-hmm. it allows a lot more alignment of value, and allows applications to be built faster, and it also allows kind of the sharing of value. So for instance, when you are first, let's say you were an early user of Facebook, right? You didn't get any more advantage than someone who joined Facebook much later. But with Web3, if you're early on, you will get more incentives. There'll be more incentive to be on that platform, because you'll get more tokens, so to speak, than someone who joins later. So there's alignment of incentive value, alignment of economic value, and that's one of the reasons why I think Web3 is going to make it, is because that really wasn't possible with Web2, right? With Web2, the value accrued with Facebook or Twitter, but the user didn't necessarily accrue any of that value. Yeah. But with Web3, the value can now be more aligned to the user because the user owns that data. Mm-hmm. And so I think it's kind of exciting times with Web3. And like I said earlier, I think pretty much any Web2 property we see, we're going to see a Web3 version of it.
Yeah. Thanks for sharing that. And so I hear, some debates when people talk about Web2 versus Web3. There are a lot of people, I just want to use the application you built for me. I don't want to own my data. I want to have a bank. I don't want, to have to create my own bank. So do you think in the future it's going to be kind of a mix of Web2, Web3 applications, more, kind of hybrid, centralized versus decentralized, or you think one will win the other?
Well, I think inherently centralized is more efficient. So, like I talked a little bit about doing stuff on-chain versus off-chain. Yeah. On-chain, the amount of competition you have is like a Stone Age, right? Stone Age computation, right? Versus off-chain, you have, so much cheap available computation available. I think because of that, I think what can be done off-chain will stay off-chain, but what has to be on-chain will stay on-chain. So I think it's going to be a hybrid. But I do think that it's going to be hard for the current Web2 incumbents to go Web3, just because it's such a seismic shift in what's going on. So I think we're going to see new players emerging, mm-hmm. That we've never heard of before. Yeah. That are, it's kind of like Facebook versus MySpace, right? I think what happens is whenever there's these kind of seismic shifts in technology, a lot of the incumbents can't make it, right? They kind of stay where they are. So if I think about Facebook, for instance, Facebook owns all the data. For them to move to a Web3 architecture, it's just hard, right? Yeah. Probably not technology wise, but but business wise, it's very hard because they have all the incentive of keeping the way it is. So there will probably be a new type of social network which is Web3 based, mm-hmm. where users own their data. and it looked quite different because, with Facebook it's all centralized. But I think what will happen with Web3 is that there'll be probably a whole bunch of different dApps that work together to create that Facebook experience. But it's hard to know what that will look like because it hasn't, Facebook, Twitter, TikTok, they're these decentralized versions of stuff is so much better that not a big incentive. But what you start to see is on in the DeFi land, right, decentralized finance, you start to see kind of like Web3 technology really take off, right? So the really neat thing is with Web3, when you sign on to a website or you sign up for a website, it's just one click. You hook up your MetaMask wallet and you're done, and that's it. Yeah. So this is kind of like it's kind of like almost like magical experience. There's no, and if you want to leave, you can take your data with you, right? It's like instant portability.
Yeah.
So it's like it's kind of magic, but it's not performant, right? It's not fast, and so Web2 technology is fast, right? So I think it's going to take some time, but just right now we're at the early days, and there's so much potential opportunity, but people are still trying to figure it out.
Yeah. And for data scientists who are interested in joining a Web3 company, what are some advice for them? How can they get in Web3?
Yeah, I think machine learning data science has become, it's like a sorting algorithm, right? Like sorting is used everywhere, right? Or like maybe a better example is like an array, right? Every programmer uses an array, right? I mean, there's, and so I think machine learning data science has almost become like that, right? It's going to be instrumental to almost every single application. Everything you could think of is going to be in there. And as right now, Web3 is kind of super early days, computation limited, but as it evolves, pretty much all those kind of things like recommendation engines or forecasts or a reinforcement RL trading bot, all that kind of stuff is going to be in Web3. It may not be on chain, but it will be used with it. So we will see the same sorts of things, same sort of ML applications used in Web3 as well.
Yeah. So if you have a good foundation, there are always going to be use cases that you can, find a job or start your own project.
Yeah. So like, here's an example, right? So I was at an event yesterday, and it was yesterday, day before yesterday, and I was talking to this professor, and he was telling me about this idea of validating your academic credentials, right? So how can you validate it, right?
Yeah.
So you could maybe validate it by looking at, like this is Web3 where you could get some sort of NFT from the place, like like I went to Caltech in Berkeley, so I could get some sort of Caltech and Berkeley or Stanford NFT, right, to prove that I was there. Because there's a lot of fake credentials, right? So and so then the question, of course, is how do you actually get that NFT, right? Because maybe the organization is not set up for it yet. So maybe there's a way you could use, ML, right? You could crawl to your social media or whatever, and and be able to reliably predict that, yeah, you are legit, right? You did go where you said you went to, right?
Yeah.
So you can see applications like this is verifying, because in the Web3 world, one of the applications out there is something called an oracle. Okay, what an oracle is basically the truth of data, and how do you know that something is true? Like whether it's an academic credential, whether it's the price of a token, and so there could be also ML applications there as well. Like how do you know what is true, right?
Yeah. I think those are all very exciting use cases for data scientists and machine learning engineers to explore. So you have been working in machine learning engineering for a long time. So what are some major shifts you have observed? For example, what are some kind of tools or models that you used to use, but now you have changed to other approaches?
Yeah, I think the big shift is this whole idea of AutoML. It used to be you had to do a lot of low-level hyperparameter tuning and this and that, but these days AutoML is really kind of alleviate a lot of the needs. And I think this makes it a lot more accessible, right?
Mm-hmm.
So pretty much all the major cloud vendors have some sort of AutoML set up where it's, you can just upload some data and plug and play and go. And I think that's very democratizing. So I think we're going to see a lot more about that. What that means for data scientists and machine learning engineers is that, that kind of low level stuff, is going to be automated away. So
Yeah.
I don't think you want to be as focused on that. I think what you have to be focused on is really around the data set and the creation of the data set, because that's something that it's hard to automate, right? So like what data should you have? How do you curate it? How do you refine it? How do you, and then also like testing, like how do you test it? How do you make sure that it's good or not good? And how do you augment your data set? So I think machine learning is shifting away from, turning all these hyperparameter knobs to, much more focused on the data, right? How do you get the data prepped in a way that the model can handle it? And all this other kind of lower level stuff like, how much dropout do you have? Or, what kind of regularization are you using? Or even for that matter, what kind of model are you choosing becomes less important because a lot of that stuff is done through AutoML. And I think that's the direction where things are headed right now, is that a lot of the low level stuff is taken care of for you.
Yeah, that's very interesting because I also observe the same. Like you can just download a model from scikit-learn or do transfer learning. There's a lot of also very advanced low-code AutoML. And what really differentiate application or data scientist is, I think, the pre-ML phase and the pre-modeling phase and the post-modeling phase, right? What data you mentioned, kind of going back to the retail store use case, you have to be creative and really understanding the business problem and then decide. So we still need data scientists to decide what data you want to create. So I think that's a really important part that would differentiate data scientists and make a project better. And then also, how do you test the model in production? How do you set up those experimentations and iterations? And then, there's always going to be this challenge with overfitting. So I think going back, I think it's kind of like a full circle. In the beginning, when we, a lot of people transition from data analysts to data scientists because they were doing a lot of kind of data processing, data collection. They want to get to the modeling part. And now we start to realize, that part is still very important. It seems very manual, but just those manual parts that make the data scientists to be hard to be automated, to be replaced. So I think that's a very important point you mentioned. And about machine learning or kind of more general solving machine learning data science problem, are there something that you learned recently that is kind of, do you have any belief shift? That's something you believed before, but now you don't believe in anymore?
I actually think, okay, so if you look at like the ratio of software engineers versus machine learning, right? Software engineering kind of dominates, right? I mean, there's like way more software engineers than machine learning.
Yeah.
I think that we're going to see more and more like machine learning versus, I think that ratio is going to, right now, I don't know what the exact ratio is, but I think it's relatively small. I think we're going to see more and more, so it's become more balanced, probably more and more machine learning folks. So I think that's one trend I see. The other trend I see is, I think, for a while there was this idea that machine learning is going to be better than humans, like superhuman performance and everything, right? You heard the story about how machine learning will replace all the radiologists, right? So if you're a radiologist, you're in deep trouble, right? It's going to, there's no need for radiologists. And, but the truth is there's still a lot of radiologists out there, right? So, I think kind of where machine learning is going to do really well is like augmenting human decision making. So for instance, Kasparov, which was, I think at one point he was the world's best chess player. If you give him like a little chess program to use, it's kind of like a calculator or whatever. He could beat like anyone, right? Because he could simulate moves. He could like, it helps his chess play, right? So now like a lot of the battles between like who the best chess players is, like, it's not just person versus person, it's person plus machine.
Yeah.
And so, because I think for a while people thought that machine will beat humans, but it hasn't really turned that way. But I think what's more powerful is the machine plus the human. I think that's something that has proven to be very effective. So I think we're going to see that as well. I mean, we kind of see that right now when we, like use our iMessage, right? Where it can make recommendations, but doesn't quite write for you, right? It gives you recommendations, so it's augmenting us. And so I think that's something which I think is, I think we like to think it's all going to be all or nothing, but it's not. A lot of times it's hybrid. So I think that's the other trend, is that we're going to see more of a, man-machine type of thing versus just machine only or human only, right? The best is going to be some sort of hybrid.
Yeah. So throughout your career, what are something you wish you have learned earlier?
The one thing that I would say that I did get right was always keep learning, right? Because there's always new technologies, whether it's machine learning or it's blockchain or it's, whatever. I think that's really important. I think the thing that I hadn't appreciated as much, I appreciate a lot more now, is making sure you work on the right problem. So you could get a lot of other stuff right, but if you're not working on the right problem, it may not matter. And so that's something which, and it's hard to know that, right? But because a lot of times you're kind of there's a lot of inertia in terms of what you're trying to do, but you may not be working the right problem or the right industry. So I think that's something which I wish I knew earlier, or appreciated more, was thinking about that as I was doing things.
Yeah.
So that's why I think being in the Web3 space makes a lot of sense, because that's where things are headed, I think.
Yeah. And so how can data scientists kind of validate the idea whether they're working on important problems?
It's hard to know, right? Because there's a tendency to go towards things right now. But, Wayne Gretzky, he's a famous hockey player. He says, you gotta skate to where the puck will be. And so, because I've seen people who are in the right industry, in the right place, they put a lot less effort, but they go a lot further because they happen to be in the right place at the right time. And so you got to kind of anticipate. If you're in what's really hot now, it may be the peak and maybe declining. So you have to kind of anticipate. So going on to these areas that are a little bit speculative is good, because there's lots of opportunity. It may blow up, it may not turn out to be anything, right?
Yeah.
Like right now, for instance, we're having this crypto meltdown. Maybe it will continue. Who knows, right? But being in these new areas, like I think internet, same thing. In the early days of the internet, some people were very skeptical that it was going to take off.
Yeah.
But now look at it, internet's everywhere. It's like, it's a powerhouse. And so I think crypto is kind of in a similar space right now. People are not sure. There's people think, oh, it's a Ponzi scheme or it's this or that. But I think it has potential to be very huge. And so I think being in that space is actually really important.
Yeah. And you have built a lot of things. You had a lot of achievement in your career. Can you share some mistakes you made?
Oh, too many. I mean, I'll tell you just about my congressional campaign. So, we thought that there would be like, 180 or maybe 200,000 people voting, right, in this primary. And it looks like, it's more like 80,000. So we're like, in terms of like estimating how many people were voting, my God, we're really off, right? Just really, really off in terms of, so we had our model. And actually, I know a lot about forecasting, but the problem with forecasting this kind of stuff is there's not a lot of data, right? And so a lot of times when there's low amounts of data, human judgment is more important than machine learning, right? Or using some sort of data science, because there's simply not enough data. Because there's only elections every 2 years or every 4 years, right? So you just there's not that much data to build good models. But our models was like way off, right? And so, and so what we should have probably done is focus more on like just the people who are going to vote versus more of a broad-based campaign. Because we talked to a lot of people who spend a lot of time and money on people who weren't going to vote, right? So that was like a big challenge with the campaign, is that we should have well, hindsight is 2020. I don't know if we could have known that ahead of time, but it's hard. It's hard. This was a guess, right? We guessed. We were off. We were really off in terms of our guess as to how many people are going to vote, and that we may just choose the wrong strategy. But so lots of mistakes. I make mistakes all the time. So, but you live and learn.
Yeah. So this one, so say if you know you don't have enough data, would you rely more on like small survey or more kind of qualitative analysis versus the quantitative models?
It's hard, right? So, I mean, elections in some ways is a really good data science problem in one way, but it's also not a good data science problem because there aren't that many data points, right? It only happens ever so often, right? And so, like, I mean, right now we're doing a postmortem trying to understand like why was our model so off, right?
Yeah.
We didn't have a very fancy model because you only have data every 2 years, right? So there's not like you have lots of data.
Yeah.
So I don't know how we correct. I mean, I read in the paper a lot of people also got it wrong. Like a lot of people were surprised by the low turnout. I mean, it's like really low turnout. Like so. I don't know. I think it's the stuff. I think low frequency things are hard to predict. I think that's the nature of it. And so like, so like you have to kind of use human judgment to kind of guess as to what's going to happen. I don't know if we could have what we could have done to make a better prediction, because like I said, there's low number of data points, so it's hard to have a fancy model. You have to kind of like use a lot of human intuition and judgment.
Yeah. Thanks for
and I
sharing
think I think we looked at, like, if you look at 2020 data, a lot of people voted, right? Like way over 200,000 people voted. But, Trump was at play, right? So there was a lot of, excitement to vote. And I think this year there wasn't, but I don't know. We'll figure out what happened. But that's definitely made a lot of mistakes. No question about it.
Yeah. And so do you have any mentors to help you, give you some advice, or you kind of just work with your peers, figure it out on their own?
No, I think mentors are actually really important. I think you want to talk to other people to learn from people. And so, like, even on city council, I have office hours where I talk to people who I largely disagree with. You want to hear other people's perspective.
Yeah.
Because sometimes it's very informative. I wish I talked to someone more about like our model for the election. But I've also had a lot of people who've given me a lot of really great advice, and I'm grateful for that. Yeah. And so I think you want to surround yourself with people who think differently than you, who can give you advice as to how they see things, because you need that kind of 360 view in order to make better decisions.
Yeah. And if you were to give some career advice to someone early in their career as data scientist or engineer, what's your best advice for them?
I think there's a really great website out there called Kaggle. You've probably heard of it. Yeah. But it's kind of like a data science machine learning competition. So right now, I'm ranked in the top 5%. But I think, you can't. I mean, you can learn by reading books and watching YouTube videos, but really the best way to learn is to do something. So I would encourage, if you're just starting out, go on Kaggle. You may not win, the $100,000 competition or whatever, but you learn, right? And you meet other people that way. So, I think there's so much opportunity in this space. I think, like I said, I think right now most application machine learning is just a small piece of it, but I think increasingly this could become the major part of it. And the rest of it, right now, machine learning is kind of like window dressing, right, so to speak. And traditional software is like the main thing. Yeah. But I think more and more, like you look at TikTok, right? TikTok, that recommendation engine in TikTok is just freaking amazing, right? It's what makes TikTok, right? And so eventually we're going to see more and more of an application that's going to be machine learning. So I think there's going to be increased demands. So I think staying with machine learning is the right field. But I think to get better at it, I think doing Kaggle competitions is a really great way to kind of build a resume, get experience, right? Meet other people. And then I think the other thing is, if you're starting early in your career, don't go after the big industry right now. Go after the emerging industry, because in the big industry, there's too many experts already, and you can't really make a mark in it, right?
Yeah.
But in an emerging industry, nobody's like Web3. Nobody's the expert. Everyone's still trying to figure it out. And so if you're just starting out, you're on the same level playing field as everyone else.
Mm-hmm.
So that's what I recommend for someone starting out right now.
Yeah. Thanks for sharing that. And so what do you think about the future of your career? Do you want to continue in politics, advocating for crypto and blockchain, and while running your company at the same time?
Yeah, for me, there's some people who get involved in politics because they want to be in office, because they always dream to be in Congress or whatever. And that was never my dream. That's not like that's some people's dream. That wasn't mine. For me, I tend to be very purpose driven. If the people in office are doing a good job, then great. But if there's a problem, like if they're trying to ban crypto, if they're trying to ban software development or something crazy like that, then I will get involved. Mm-hmm. I think I ran, and a lot of people suddenly started coming up with pro crypto platforms. I think that's amazing. I think that's great. Unfortunately, the current incumbent really hasn't done that yet, but but maybe she'll change her mind eventually. I don't know. So I think so for me, I'll go for elected office if I need to, right? If it looks like nobody else is going to help, kind of help promote innovation, help promote entrepreneurship, then I'll certainly step in. But I also, in act of running, I had so many people tell me that the current representative has never been more responsive. So I think that's also something that I think is important, right? Before she's kind of known as being super hard to get a hold of, right? Super hard to get a meeting, right? She'd never show up at your campaign event. And now people tell me that she's never been nicer. She's never, so I think that's good, actually. I think competition is always good, right? And so we want to keep our political leaders, honest. And I think people running against them is important, right? I think people should, like for instance, I got reelected to city council, but it keeps me honest and makes sure that I do a good job. Because if I don't do a good job, I don't get reelected. So I think that's important, because so often, especially for Congress, no one really runs against them, right? So you get the same people all the time, and you get these kind of incumbents who've been in office for 30 plus years, and they don't do a whole lot. And so I think we want our representatives to work for them, work for the people. So I think competition is good, and so I think it's good that people run against them, right? To kind of
it's like the GANs model. You want to train one against
GANs, exactly. It's like the GANs, yeah. It's like the GANs, right? You got to have competition. Competition is always good. It brings out the best of everyone, of everything, right?
Yeah.
Yeah. So GANs is a good analogy.
Yeah. And just like you mentioned before, if one is always winning, the other doesn't learn, then the overall it's kind of not good for the overall model. Right?
No,
you want to have this type of healthy competition. And
so that, by the way, that's what can also be said about the state of California. Right now, the Democratic Party is so strong here, right? So it's kind of like the situation right now. The Republican Party is so weak. And so, at least here in California, so you don't have this competition between the two like you used to have. So that is challenging, right? But yeah, it's kind of like, I think your analogy is really good.
And right now, so what is something you're excited about in your life or in your career, for example, this year we're going to work on next?
I have a bunch of Web3 things that I'm really interested in. I mean, one of the things that we did was we formed a DAO for the campaign, Tanaka-the. And so that was really interesting because I never really got involved in DAOs. So what DAOs are is decentralized autonomous organizations and NFTs. So I think there's new ways of building community, of getting people involved. I think that's really cool. And so I'm really interested because I think it's kind of like it's like almost like a social experiment, right? It's a new way, because a lot of times when you volunteer on something, it's just kind of like you donate your time, but you don't really get anything back. But I think with NFTs and DAOs, there's new ways of organizing people that could be very, very interesting. So I'm really kind of thinking heavily about this kind of Web3 space. I think there's a lot of interesting possibilities. And so that's kind of like the part that I'm really excited about is just, I think this is like the internet in 1995, literally. I think that we're going to see so many cool applications come out. And so this is a time to kind of have a new mark in the world, right?
Yeah. That's very exciting. And then I will ask you to send me the link of your DAO. I will link it in the show notes if folks
Oh
are
yeah, please.
joining. Yeah. So before we wrap up, if for folks who want to follow your career journey, your next steps, where can they find you online?
At Greg Tanaka on Twitter, and then I'm also on Instagram. I think I'm Greg Tanaka or Greg Tanaka. LinkedIn. I'm pretty much on all the different platforms. So love to connect with people and happy to chat with anyone.
Yeah, that's awesome. It was great to have you on the Data Scientist Show. I really enjoyed talking about a wide range of topics from forecasting to Web3. And thanks again for sharing your journey with us. It's very inspiring, and looking forward to your future projects.
Thank you so much. And thank you for doing this show. I think it's amazing. So I really appreciate the opportunity.
Thank you.